The next division type we're going to do is synthetic division. This is actually the preferred method because it's much quicker. Okay, it's just using the coefficients, and once you get the hang of it, you can do the synthetic very quickly. All right. So what we're going to do is we're going to divide 2x cubed minus 7x squared plus 5 by x minus 3. Now, since we're only using the coefficients, we're going to have to make sure that we put placeholders here again in our polynomial. The polynomial always gets placeholders. P of x needs placeholders. All right, so this one is going to need a placeholder for the x term here. And then in synthetic division, we're not dividing by x minus 3, we're dividing by the 0. So this is like our factor. So if x minus 3 is the factor, then 3 is the 0. So we would do x minus 3 equal to 0. Solve this. 3 is the 0, right, from section 3.2. So I'm going to put the 0 in a little box. Okay, positive 3. And then I'm going to list the coefficients next to this little box in descending order with placeholders. So we have a 2x cubed, a negative 7x squared, no x term, and a constant of 5. So sometimes I like to kind of make sure I know that I have x cubed, x squared, x, and constant. Right? Skip a space, draw a line. Okay? We're going to fill this in just a minute. Now the first step in synthetic division is we're going to add down first. And we're always going to add down. In long division, we subtract. In synthetic division, we're going to add. So there is nothing here. We're not going to ever put anything here. So we're always just going to bring the 2 down. Okay, so add down first. 2 and nothing is 2. And then we're going to start the synthetic division process. We're going to do 3 times 2 and put it in the next adjacent spot. Right? So 3 times 2 is 6. The 6 is going to go underneath the negative 7. And then we add down. Okay, negative 7 and 6 is negative 1. And then we're going to do it again. 3 times negative 1, put it in the next adjacent spot. So a negative 3 is going to go here. Add down. And then 3 times negative 3 is going to go in the next adjacent spot. So 3 times negative 3 is negative 9. Add down. This is our answer. We just have to interpret it correctly. Right? The answer column is always 1 degree less than what we started with. So since we started with an x cubed column, this is the x squared coefficient. The negative 1 is the x coefficient. The negative 3 is the constant. And the negative 4 is the remainder. Right? So this here is our quotient. And this here is our remainder. Now, synthetic division can only be used when your divisor is linear, which means your remainder is always going to be a constant. And that's really important. We could not have used synthetic division here when our divisor is quadratic. We only can use synthetic division when the divisor is linear and the 0 is easily found. Right? So, I wanted to do P of x equals Q of x times D of x plus R of x here. The quotient is everything but the remainder down here. So the quotient is 2x squared minus x minus 3. The divisor is what we're dividing by, but we're not just dividing by 3. The divisor is here. Okay, x minus 3. Plus the remainder is the last number we're left with, negative 4. So we are going to be using synthetic division quite a bit, especially in section 3.4, but there is really 2 important theorems in this rest of this section, the remainder theorem and the factor theorem. Right? So the remainder theorem says if the polynomial is divided by x minus c, then the remainder is the value of p of c. This is saying we don't have to divide. All we have to do is plug that 0 into our polynomial, and we'll get the remainder. So I'd like you to see that in action. I would like to try synthetic division one more time so that we can practice this, right? So I am going to do the division here and get a remainder, and then I'm going to show you that it's the same thing as what this theorem is going to say. So I want to divide this polynomial by x plus 2. So if x plus 2 is the factor, then negative 2 is the 0. So we're going to divide by negative 2. And again, if we wanted to get the 0, we just set it equal to 0 and solve, right? So we get x equals negative 2. Now I need to list our coefficients out in descending order with placeholders. So I'm going to quickly glance. I have a 5th degree, 4th degree, 3rd degree. We're missing the 2nd degree, so I need a placeholder there. Linear constant. So I'm going to put 3, 5, negative 4, 0, 7, 3. So 5th degree, 4th degree, 3rd degree, square, 1st, and constant. Okay, make sure you put in those placeholders or you're going to get an incorrect result. The first step in synthetic division, add down. Okay, 3 and nothing is still 3. Bring that 3 down because you've got to have something to multiply by. So now we're going to multiply, put it in the next adjacent spot. So negative 2 times 3 is negative 6. Add down. Negative 2 times negative 1 in the next adjacent spot. Add down. Negative 2 times negative 2 in the next adjacent spot. Add down. Negative 2 times 4 in the next adjacent spot. Add down. Negative 2 times negative 1. Add down. Right? So we have the quotient and the remainder. The quotient is everything but the last number here. So remember, these are 1 degree less. So we started off with a 3x to the 5th. So this is 3x to the 4th, x cubed, x squared, x, constant, and remainder. So this question did actually ask for the quotient and the remainder. So I'm going to go ahead and state the quotient. It's everything stopping at the constant. So we're going to get 3x to the 4th minus x cubed minus 2x squared plus 4x minus 1. And then the remainder is just a constant, 5, because our divisor was linear. So next, on B, okay, use the remainder theorem to find p of negative 2. So the reason why they're plugging negative 2 in there is because they're plugging the 0 in there. So if p of x, up here again, if p of x is divided by x minus c, the remainder is p of c, right? X minus c is the factor, and c is the 0. So we're plugging the 0 in there. So if x plus 2 is the factor, then negative 2 is the 0, and that's what we want to plug into our polynomial. So if I plug negative 2 into the polynomial, right, this is going to be some big numbers here, but we can do it. 3 times negative 2 to the 5th plus 5 times negative 2 to the 4th minus 4 times negative 2 cubed plus 7 times negative 2 plus 3. If we multiply all this out, we should be getting 5. Okay, so negative 2 to the 5th is negative 32. Negative 2 to the 4th is positive 16. Negative 2 cubed is negative 8. I guess I could put negative 14 here, plus 3. I'm going to go ahead and reach for my calculator because I don't feel like multiplying that out with my hand at the moment. All right, so 3 times negative 32 plus 5 times 16 minus 4 times negative 8 minus 14 plus 3. Fingers crossed. Right? I did get 5. Right? So the remainder is equal to the function evaluated at the 0, which is kind of a cool little fact about long division and remainders. Now what's next is the factor theorem, and that's even more powerful. Okay, so on the next page, the factor theorem says C is a 0 of P if and only if X minus C is a factor. Well, actually, I would rather say if the remainder is 0, then X minus C is a factor. Okay, so if if P of C equals 0, then X minus C is a factor. We're really going to kind of focus on finding polynomials and factors that give us a 0 remainder. Because if we have a 0 remainder, then we know we have a factor. Right? So we're always going to try and look for the fact that we get no remainder. That means it divides evenly. So on number 5, let P of X equal X cubed minus 7X plus 6. Show that P of 1 equals 0 and use this fact to factor P of X completely. So first off, let's plug 1 into the polynomial. So we're going to get 1 cubed minus 7 times 1 plus 6. So 1 minus 7 plus 6, 7 and negative 7, you can tell that's 0, right? So we kind of proved it to ourselves. Now how do we use that fact to factor the polynomial? We have to do synthetic division. Okay, so P1 is the 0 here, right? When we plug it in, we get the 0. So X minus 1 is the factor, and positive 1 is the 0. I want you to kind of keep that straight. In order to factor P of X, we need to know what the quotient is when we divide this. So I'm going to divide this polynomial by the 0. So I'm going to put the 1 in the little box. I'm going to list the coefficients out in descending order with placeholders. So X cubed, we're missing the X squared here. X constant. So I'm going to make sure I put a 0 there. So 1X cubed, 0X squared, negative 7X plus 6. So the first step in synthetic division, add down. 1 times 1 in the next adjacent spot. 0 and 1 add down is 1. Multiply, put it in the next adjacent spot. Add down. 1 times negative 6 in the next adjacent spot. Add down. Right. So this time we got a 0 remainder. So we started off with an X cubed, X squared, X constant. The answer row is 1 degree less. This is the X squared, this is the X, this is the constant, and this is the remainder. So notice when we do P of X equals Q of X times D of X plus R of X, our R of X is going to be 0. So we're going to get the polynomial is the quotient times the divisor only. So our quotient is X squared plus X minus 6. Okay, and our divisor isn't 1, it's the factor, right? So then our factor is X minus 1. So here the polynomial is factored. Now it's not factored completely because if our factors factor, we've got to keep going. So this quadratic would factor one more time to get X plus 3, X minus 2, and then the X minus 1 is still there. So here is our polynomial completely factored. All right, I'm going to work the next example in the next video.